Let's walk through this example in the Examples folder, which sets the drive's frequency, acceleration and deceleration times, enables the drive, issues the run stop, and forward and reverse commands. It also does a drive fault reset. I moved the menu buttons to make more room on this screen, so don't be surprised if this looks a little different than yours. If you don't see the comments, then make sure the Show Comments button is on. Rung 0 says when we set the internal general purpose M1 bit, set the frequency and the ramp times. I can never remember which register's which, so let's right-click and edit the register comments. D50 is the frequency with 2 implied decimal places, D52 is the acceleration time with 2 decimal places, and D53 is the deceleration, also with 2 implied decimal places. That's much better. Of course, these D registers will need to be preloaded with these values before running this command. In this example, we'll do that with the register monitor when we go online with the drive. Well, that rung used 8 of our 10,000 steps, so the next rung starts at step 8, where we use input X0 to enable the drive. That's not the run stop command, it just enables the drive's outputs. The comment says power on. Think of that as applying power to the output stage of the drive. The row comment reminds us that X0 is what the drive refers to as the forward input, and use that input as the drive enable by enabling this special function register in the output coil. The next row uses the drive's reverse input as the run stop control by enabling this special function register. The next rung uses input X2 to control the forward and reverse via this special function register, and this rung uses X3 to reset the fault. Let's select the COM port that our USB to RS-485 adapter is plugged into. These are the correct COM parameters, and we do on RTU. Perfect. Let's write this program to the drive, go online, put the drive in run mode, and open the monitor window. Let's add the M1 control register and the frequency, acceleration, and deceleration registers. Let's set the drive's frequency at 60 Hz, remember the 2 implied decimal places, and the ramp times to be 5 Hz, again with 2 implied decimal places. Let's toggle M1 to set the frequency and the ramp times. I have some switches connected to the drive's inputs, so I'll enable X0 to power up the drive's output, set the forward switch, and set the run switch. And sure enough, the drive ramps up to speed over 5 seconds. Perfect. Well, that's really all there is to it. But there are a number of things you need to know to get the most out of your GS4 drive when controlling it from the built-in PLC. We'll cover all of that in Part 2. Click here to learn more about the GS4 drives. Click here to learn about Automation Direct's free support options, and click here to subscribe to Automation Direct's YouTube channel so you'll be notified when we publish new videos.